Hi, this is Karen, and in this video we share examples to help you understand the independent samples t-test and the analysis of variance, also called ANOVA. To explain what these analyses do, we're going to focus on the adage about comparing apples and oranges. At the end of the day, that's what both of these tests tell you. They help you figure out if groups of people in your data are acting like apples of different shades, and so really versions of the same thing, or if groups of people in your data set are acting like apples and oranges and how they evaluate your event. Let's unpack that for a minute. What does it mean to act like an apple or an orange? Evaluation data often consist of ratings that were collected from people who have one important thing in common. They all participated in your event or intervention. In that way, they all acted like an apple. They might act like apples in lots of other ways too. They could be from the same age group, or attend the same school, or maybe they all really like science. There are also some known differences, like maybe some identify as boys and others identify as girls. The t-test and ANOVA focus on these known differences to see if the groups in your data also differ in how they rate your event. When they do, people are acting like apples and oranges based on the group they belong to. Your evaluation questions help you figure out which groups you need to explore. For example, you might need to analyze whether family and adult groups acted like apples in your data by providing similar ratings for the same event. Or if they acted like apples and oranges because those who attended with a family provided higher ratings than those who attended with adults only. Or maybe you want to know if there are differences in how engaging one exhibit is compared to another. In this case, the exhibits are acting like apples and oranges if the engagement ratings for one are higher than the other. In each case, you tell the statistical program what groups you want to learn about and the rating or continuous variable that you want to analyze. The statistical test assumes that the groups act like apples and thus are the same. If p is greater than 0.05, then your groups are acting like apples in your data. If you get a statistically significant result of p less than 0.05, then the test has indicated that the groups in your data are behaving like apples and oranges in relation to the variable being tested. The way these statistics figure out how groups act is by calculating the mean and the variance for each group. Let's say that this perfectly red apple represents the average score for a group, which was created by adding up everybody's individual score and dividing by the number of people in that group. The statistics also look at the variability around the mean, which we're showing here by the different shades. The variance represents how far away from the group average each person's score actually is. Both the independent samples t-test and the ANOVA create these scores for your groups and then use them to calculate a test statistic. If you get a significant p-value for either the t-test or the ANOVA, it means groups are acting like apples and oranges in your data. Here are some examples. Let's say that group 1 had scores that looked like this, where each apple is a person's score. Looking at this distribution, we can guess that the mean is going to be somewhere near 50, because we have the most scores clustered in that part of the curve. We can also see that scores range across the full scale, from almost 0 up to the top score of 100. Let's say that group 2 had scores that looked like this. Overall, this distribution is slightly tighter than the first group, since scores seem to range from about 10 to about 95. The mean or average for this group is likely to be slightly higher as well, since the highest scores cluster slightly above 50. Because the means are pretty close, and the scores from one group overlap a lot with the scores from the other, we might expect this to be a non-significant result. Both groups are acting the same. They're acting like apples in our data. But let's say that our groups looked like this instead, where one group has scores in the middle of the scale, and the other has scores clustered closer to the top. In this scenario, we might expect a significant result, telling us that our groups have acted like apples and oranges in our data. But what about something like this, where the mean looks similar and there is overlap between the scores, even though the distributions are different? In these cases, looking at the means on your own might lead you to believe that there aren't any differences between these groups. It looks like our groups are acting like apples. The combined use of the mean and variance by the statistics that we choose help determine instances where we have groups that look like they're acting like apples, but that are actually acting like apples and oranges. So how do you know which one to use, the t-test or the ANOVA? It often comes down to group size. The t-test can only work with two groups. If you only care about differences between two groups in your data, that is apples versus oranges, then the t-test may be for you. The ANOVA works with two groups as well, but can also explore more than two groups. If you want to know if people in your data are acting like apples, oranges, pears, and nectarines, then you have to use the ANOVA. For example, you might need to look at museum revenue by quarter, or maybe you need to document differences in event attendance based on neighborhood. The ANOVA would help you figure out if you've got differences across the 4 quarters of the year or across the 3 different zip codes in your data. Like all statistical results, whether your findings are a good thing or whether they're unwelcome news depends on the goals of the program and the purpose of your analysis. These analyses just tell you if your data are similar or different across groups. It's up to you to interpret the results based on the goals of the event you're evaluating and your rationale for doing the analysis in the first place. At this point, you might be wondering how this analysis is different from the chi-square test that we also present in this video series. The difference comes down to your outcome variable. If you need to know if being part of one group relates to how people fit into another category or group, then you need the chi-square test. If your outcome is a rating variable with at least 5 categories or a continuous variable, then you need the t-test or ANOVA to explore group differences. We hope this video provided you with a basic understanding of how independent samples t-tests and ANOVAs work. You can watch our other tutorials to learn how to conduct each of these analyses in Excel, SPSS, and R. For now, this is Karen signing off. Thanks for watching and good luck.